Yeah, critical numbers and endpoints are what we're looking for here. So the endpoints most often are quite obvious. They're right there, -1 and 3. Critical points, critical numbers, where do they happen? In general, critical numbers happen where?
When f prime equals 0.
Yeah. McKenna, you got it. So f prime equals 0, or, let's not forget this one, sometimes DNE is an important thing to consider. So critical points happen where f prime is either 0 or DNE. That's where those are going to come from. So if we're going to be finding f prime equals 0 or DNE, we probably should want to have f prime first. Do we have it right now? We have f. We need to find f prime. So we're going to do a derivative. So let's do that really quick. I'll do it quietly up here. You guys can work on it there, and we'll compare notes. You guys feel rusty?
Yes.
All right. Well, if it seems like I'm going too fast at some point and assuming too much, just let me know and ask a question, and I'll be happy to help. I hope you're all comfortable with each other enough to where you can shoot a hand up and be like, whoa, slow down, wait a minute, I didn't get that part. Please do. Please do say something. Okay, so using the power rule twice, I got f prime equals 2 minus 2x to the -1/3. We have a little cancellation with the 3's there. Does that make sense? Okay. Then I'm going to say equals 0. So this is kind of a complicated equation to solve. What would you do first if you were going to try to solve this? Algebra on day 1. Dun, dun, dun.
Oh, to the other side, yes. To the other side.
Get something to the other side. Okay, sure. So 2 equals 2x to the -1/3. I can live with that. What would you do next? Divide by 2. You guys are avoiding it, aren't you?
Yep.
So we've done all the easy stuff. What do we do with this now?
Take everything with their
We could take everything to the -3. That's actually a pretty cool strategy, right? Because -1/3 times -3 is 1, right? So I like Lenny's idea. No, that was Darian. Or Lenny, did you say? Okay, there was just a chorus. So Darian kind of came up with it at the start, it looked like. Okay, so take both sides to the -3. You could have just flipped the x to the -1/3 down and done like a cross multiplication. That would have worked too. Bottom line is, don't we get x equals 1? Okay. That's a critical number. There's another one. Do you know what it is? Takes no algebra steps whatsoever. Those are endpoints, which are not necessarily critical numbers. Those are candidates, though. We'll use those. There's x equals 0. Why is x equals 0 a critical number?
Because like x to the -1/3, since it's a negative exponent, x equals 0.
It's really a denominator, isn't it? Yep. And so when you look back up here, this is really a recognition point. Because you got x to a negative exponent, technically that means that it's an x in the denominator. So if x were 0, you'd have a 0 in the denominator, which is not okay, meaning that you'd have f prime DNE. And so we've got two critical numbers right there, 0 and 1. At this point, what we would do is we'd make a table, and we'd have all of our candidates. Our candidates would be endpoints like -1, critical numbers like 0, 1, and then the other endpoint, which is 3. And then we take those candidates and we plug them into something. Do you guys remember what we plug them into? F of x, right? Because all we're really doing is comparing the y values of f of x, which one's higher, which one's lower. We are up against our time right here. Can you guys each take one of these real quick? Use your calculators if you've got them.
I got 0.
Oh, you got 0? So what's the output for 0?
-1. Oh, I have
0, okay.
I got 1.
When you plug in 1, what do you get?
-1.
-1, good.
If you plug in -1, you get -5.
Yep, agreed. So those three are actually pretty straightforward. It's the 3 that we really need the calculator for.
6 minus 3 times the cube root of 9.
Let's go do a decimal so we can compare. Although we could probably do something.
-0.24.
Negative.
0.24.
Let's do the 3 decimals in honor of what we're supposed to do.
0.240.
240, okay. Negative 0.240. So at that point, what we can do is just call out the max and the min. So we'd say the max is what? Yeah, the max is 0. And I'm looking at this for that. And then the min is, nope, negative 5. Oh, you know what? You bring up a fair point right there. I would say that the min is at x equals -1, but it is -5. Right, so location would be an x value, and then the actual value would be the what it is. So, get what you're saying there for sure. You can list both coordinates. They don't get too upset about that. Sometimes they get a little upset, but anyway. All right, I hope that helped you shake